Having proven the quotient rule, we're now in a position to look at the derivatives of the remaining 4 trigonometric functions. Now here we have a table listing the derivatives of all of our trig functions. Now we already looked at the derivative of sine equaling cosine, so we've already done that one, and the derivative of cosine is negative sine. Now the other 4 trig functions are as follows. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant times tangent. And derivative of cosecant is negative cosecant times cotangent. Now there's a pattern here that you can recognize, and if you think of the functions as being partners, like sine x being a partner with cosine of x, tangent of x being a partner with the cotangent, and secant of x being a partner with the cosecant. Think of these as being the partners of each other, and then you can easily remember these 6 trig derivatives. For example, derivative of tangent is secant squared. So if you remember that one, then you can easily recover that the derivative of cotangent is negative cosecant squared if you realize that the partner of tangent is cotangent and the partner of secant is cosecant. Now you do have to remember that negative there. Derivative of secant is secant times tangent. The partner of secant is cosecant, and so the derivative of cosecant is going to be negative cosecant times cotangent, where this cosecant is the partner of secant and the cotangent is the partner of tangent. So if you think of the 6 trig functions as being partners down here like this, you can really just get away with memorizing 3 of these. Derivative of sine is cosine, derivative of tangent is secant squared, and derivative of secant is secant times tangent. Then you can recover the derivatives of the other 3 if you remember that the cosine partners with sine, secant partners with cosecant, and the cotangent partners with tangent, and then you have to remember the negatives. Now let's take a look at the proof of one of these. Let's prove that the derivative of tangent is secant squared. Now we have to recall the quotient rule here. So if we want to prove derivative of tangent is secant squared, we start with this. And now tangent is sine over cosine. Now we just have to apply the quotient rule here. So this will equal cosine times the derivative of sine x minus the top sine x and then all of that is being divided by cosine squared x. Now the derivative of sine here, that's cosine x, and the derivative of cosine is negative sine x. And so substituting those in, we get that this is equal to alright, so we get cosine squared x plus sine squared x. Notice the minus changed to a plus because of these 2 minuses here and here canceling each other and giving us a plus. Now remember the trig identity, cosine squared x plus sine squared x, this is going to equal 1. This equals 1. Cosine squared plus sine squared is 1, and so we end up with 1 over the cosine squared x, and that is the secant squared. Noting that 1 over cosine x is secant x. And that's what we wanted to prove. Let's take a look at one more. Let's prove that the derivative of secant is secant times tangent. So if we start with now secant is 1 over cosine. Oops, let me fix that. Okay. Secant is 1 over cosine. Now we can apply the quotient rule to this. So we're going to get cosine times derivative of 1. Now the derivative of 1 is just 0, so we're just going to get here 0 cosine x times the derivative of 1, that's 0, minus 1 times the derivative of cosine is negative sine, divided by cosine squared x. And we end up with and we're going to break that up as follows. We'll write that as so we just split this fraction apart as follows. See, if you multiply this together, you get sine over cosine squared. Now, 1 over cosine, that's the secant, and sine over cosine, that's the tangent. And that's what we wanted to prove. So we've proven now that the derivative of secant is secant times tangent. Let's take a look at an example. So let's evaluate the derivative of x squared times tangent minus the cotangent. Alright, so f prime of x. For this part right here, we have to apply the product rule. So we're going to go x squared times derivative of tangent plus tangent x times the derivative of x squared, and then the derivative of cotangent. Now the derivative of cotangent is negative cosecant squared x, so we'll write that like this. Change that to a minus. Alright, now remember I know that because the derivative of tangent, I remember derivative of tangent is secant squared, and cotangent is partner of tangent, so the derivative of cotangent is going to be cosecant squared x, but with a negative. Alright, and now we can simplify this as derivative of tangent is secant squared x. Derivative of x squared is 2x, so I'll write this as 2x times tangent x. And then we just have cosecant squared x out here. And that's our derivative. That's all we had to do. Alright, so that concludes this lesson on the derivatives of the trig functions.